Chapter 8: Circumferential and longitudinal stresses in a thin wall pressure vessels like cylindrical vessels. A barrel of wine or water can be considered as a cylindrical vessel. We are going to study the effect of longitudinal stress and circumferential all around the barrel. So if you consider this volumetric cylindrical volumetric shape considered as a storage, gas storage, oil or water storage tank, you can observe in this element two kind of stresses: one in x direction, which is sigma 2 longitudinal stress all around, and the other is which travels around this strip in uh, all around the cylinder. So sigma 1 is the pressure of the fluid, either gas or water, times the radius of the tank over the thickness of your cylinder. And that's a visual representation of that. And the other one is sigma 2, which just goes by PR times 2T this time, and it's just applied here. If we have a closer look to the circumferential one, sigma 1, you can consider this element with the length of dy and thickness of t. So to calculate sigma 1, you can consider, and sigma 1 is nothing but circumferential or hoop stress. If you develop the summation of forces in positive x direction and you call it positive x direction, too often, because you have one at the top and the one at the bottom, 2 sigma 1 times the area. 2 sigma 1 times area of our element dy times t should be cancelled out by the inside pressure of the liquid or gas, and which applies to the height of 2r and the thickness again dy, 2r times dy, and that should go 0. And if you cancel out dy and 2 with each other, you can easily calculate sigma 1, which is the pressure inside the vessel, times the radius of the tank over the thickness, which you can observe here. Likewise, if we want to observe the longitudinal stress, which is sigma 2, you can easily see that sigma 2 acts uniformly through the wall. This is sigma 2 and shown in green, and just apply to this narrow strip of the thickness, and that's is nothing but 2 PRT, 2 pi times r times the thickness, and that's the effect of sigma 2. And we do have another pressure, which is the internal gas or liquid pressure, which applies to the entire area of the circle, which is shown by the red arrows oppositing sigma 2 in direction, and in yellowish area, which is pi r squared. That goes by pressure inside the tanks times pi r times r squared, and contradicts sigma 2. And if that's equal to 0, it just gives you sigma 2 is equal p times r over 2t this time, as you can observe here. If we want to show that effect in a more pronounced, if that's the end part of a cylindrical vessel with a solid semisphere cap, you can easily see the effect of two contradicting force. You can also see that here, and we can also show that in more pronounced with the two different kind of forces: sigma 2 dA in green area, which is to the positive x direction, and that's sigma 2 or longitudinal stress. Mhm. And P is the shown by this yellowish area, which applies to P pi times r squared, which is PdA. Again, for a conclusion, one can say by observing two different stresses in a cylindrical vessel, one can easily say the circumferential stress is as twice as the longitudinal stress. You can observe it here.